Okay, hey guys, so I guess we're gonna start now. And so it's been brought to my attention that some people, so who here can make it for the entire 2 hours till 8? Most people? Okay. But what I thought I'd do is start out by trying to get a sense of what people are struggling with and what questions they have, and just sort of quickly jot down if there's any sort of clustering of things that people want to learn more about. So does anyone want to start us out? Who here has questions? Okay, sure. Go ahead.
So I agree. So my question is, using generic model structure and creating four adaptive points, creating a modeling profile for each of those points, getting a form.
Okay.
So you get a box of values.
Okay.
It's how you, and then apply that to the surface.
Okay.
It's not adaptive to surface, and it should be adaptive because it creates the generic adaptive.
Okay. Okay. So you're struggling with making the adaptive components, but you're still making it from 4 points, and it has a kind of thickness, and you're trying to get it to that.
It's not complex. It's not 4 points.
Okay.
It's every profile that has those paragraphs. We did like all the details of class and the wall statements.
Okay. So this is an adaptive component from more than 4 points.
Yeah. Yes.
It's like it's a profile with the common break and the connectors and everything.
Okay.
So when you extrude the profile, it just gives you the whole very clearly. And that cannot be curved on the surface.
Okay. I'm not going to lose track of these, but I'm just writing them down here just to get a sense of like what are the areas. Yeah.
I have like the same kind of problem. It's like I have 4 points, but it's not curving onto the surface. It's just like so. I don't know how to get the form to curve on.
Okay.
So like be applied to the surface.
Okay. Okay. So 4 points adaptive component, but it's not actually curving onto this. Okay. Anyone else? Any other questions?
Yeah. One more.
So,
well, just to make sure did you have one?
Yeah. So.
Oh.
So our facade panel is made up of multiple families. How to combine like assemble multiple pieces into one facade panel?
Okay.
Each piece is parameterized and adaptive.
Okay. Okay, that's good. Subfamilies in Revit, or families that have families inside of them. Okay.
I'm having issues with like the order of points within a list. So there are methods for like moving. Yeah.
Okay, that's managed. Okay.
In the description, you ask to calculate the accuracy for reference circles.
Okay, so yeah.
The maximum possible deviation of each panel from the reference circles.
Okay. And you were wondering how to calculate this, or what it is, or okay.
Maybe calculate.
Okay. So any other, and just sort of, I don't see too many, it looks like there's 2 issues with adaptive components, so I might start there. The list management stuff, I think I can try and give you some tools, but then there's also some good online tutorials. Glenn, do you actually know how to, are you kind of a Revit guru enough to know how to make a family inside of a family? Okay, I mean, would you mind like demonstrating some of that some time during this? Because I actually don't know how to do that. Or if it's straightforward, maybe I can sort of noodle around through it as well. But if it sounds like, I think it sounded like you had like an adaptive component detail that had, for instance, perhaps like a mullion that was the family inside of the adaptive component family, or as like an example.
So we created multiple face-based, multiple generic face-based families. Some pieces are like there are 2 pieces of aluminum. One is the exterior, one is the interior. We have like 3 different shapes of thermal rays. And then how do you assemble those together in a generic adaptive model?
kind of interesting. Okay, so they in turn, the subparts, they're going to have adaptive points to guide where they're going.
Yeah, and then what I saw in the video is, so each of those separate families has its own adaptive points.
Sure.
And then in the big family, you have the whole planet has its own 4 adaptive points. It's a rectangle, and then it has reference points, and on those reference points, the adaptive points from the individual family sits on those reference points.
Sure. Yeah, so it's interesting. A simple test case would be, like, let's say you have the 3-point beam or something like that. Yeah, basically, you, in an outer family, you want to go ahead and put like 3 points that in turn will adapt to whatever you place that in. But then internally, we're gonna basically place the subcomponent, the subpart, on those adaptive points and stick to them.
Yep.
So that they'll move around. Okay. We've tried noodling around with it. I've never tried that, but the principle should be the same. It's going to stick. As what we've done, kind of like we've been playing around with Rivet, part families, embedding parts within other parts, like we did in the part family. We can play. Actually, start with something else, Patrick.
Sure.
I'll do a little quick little unit test on that and see if I can come up with a good example to show you that. Because I think that might actually be not so hard.
So regarding the first question about the adaptive components, not sort of, because I think I'll start with like what you're asking about let's make sure everyone's on the same page about how we can get an adaptive component onto a surface. So here I just have a very simple one loaded into, or opened up into Revit. And so what I'll want to click on here is the load into project, and I have a previous architectural project already started. So this is just a key step to make sure that this family has been instantiated into our Revit document. I'll then go ahead and open up Dynamo. I'll import the form. So it looks like I think some people were having trouble importing the geometry from Revit.
Yeah, that's one of the problems.
Okay.
I import like the shape, and then all the layers are completely different. They're not layers, the curves are completely different from your.
So one thing that I was able to do that worked pretty well was to just export the city hall as a SAT file. So if I just run this here, you should be able to see now I have the exact same form that was in Revit as a SAT file in here. So I can tell that I can start getting elements from here just with a simple code block node. Let's see.
Okay, do you select uncheck preview to see just the layer?
Yeah, so if I have this selected, then all the imported geometry will appear, and this box here will kind of illustrate what geometry has been imported. So if we have a solid here, we'll still want to extract out, say, the faces of this solid. So extract this guy here. So I'll go over what I'm doing here just really quickly. right, so sorry about that. Again, going back to what I did before, is before, if we take our Revit model of the city hall, we can export it as a SAT if you're having trouble importing it. But just going through these steps here, when you import this, these elements, you're going to end up with a huge number of objects. So we can tell there's a solid here, there's some surfaces and some more solids. I'm extracting out one of the solids here, and then I'm exploding it using this geometry explode, which is essentially going to take this solid and explode it into the constituent surfaces. This is kind of like a Rhino concept. And now they have this surface here, I can start getting, say, quad points on surface, or quad points on face. So again, if I just plug in 10, 10, I'll end up with a whole series of points here. Sure. So again, without looking at your file, how is your script differing from what I've kind of just shown here? Because what I was in this relatively quick script, I'm just taking 4 points. I make sure that my adaptive component has 4 points.
I mean, I was basically the same, but for the curved panel, I want the panels to curve on the building, like on the
Okay.
edge of the building. So I want like the edges of each panel to be curved.
Okay.
So basically like flat panels, right?
Mm-hmm. All right. Okay. So this is probably how I'd recommend going about doing it. But I'm not going to go into the complete detail. I think this is actually going to go into the list management a bit later, but I think it'll get you started in the right direction. So essentially what I've done similarly is I have my SAT file, I've exploded it, and now I've done quad points on face. But there's a surface UV parameter at point, which is essentially going to do the inverse. Now, of course, you actually could come up with this parameterization yourself. Like this is, it's going from 0 to 1, and then you're really just taking 0 to 1 and dividing up into 10 sub-elements. But this is just easier for me because Zach's already come up with this quad point on face node. So I have a set of quad points, and this is basically going to turn those quad sets of 4 points into sets of 4 UV parameters. And then I'll use that to essentially create these curved by parameter lines of surface. Now, if you're going this route, you're probably going to want to do a lot more of your modeling in Dynamo. So that's probably the trade-off, is you won't be able to model the whole thing completely as an adaptive component. So in other words, if this adaptive component only accepts points, it doesn't have any notion of what's the curvature at that given point. Now, so this is one simple like solution to it. Is basically now you're creating several lines or perimeter lines that represent the form of your mullion or window detail, and you're going to just model those directly in Dynamo. Now, one other option that comes to mind as I'm thinking about this is you can also say extract the coordinate system at parameter on a surface. And so again, if I take my surface here and I take the let's say 0.5, and we look at the output here, the length of these these XYZ, the XYZ vectors should indicate actually curvature. I don't remember if this is true. The curvature should indicate, basically the curvature of the surface should be indicated by this coordinate system that we're extracting off of here. So you can basically determine how curved that surface is at a given parameter, and then perhaps feed that back into your adaptive component. So this would be an instance where if you have your adaptive component here, you have to expose some sort of property that says, like, I have 4 points, and it would tell you how much that should be curving based on the curvature that you've extracted out of Dynamo. There we go. So does that kind of help you push you in the right direction, or is there anything else, I can help you out?
You have you would model in Dynamo without having like an adaptive component that would do everything, like the curve itself. How would you take that out, take those lines, and make that into Revit?
Well, I mean, if you absolutely need it to be in Revit, I don't know if that's necessarily a requirement for the class, but you can of course create a Revit curve from these curves, for instance. So, okay. Curve element. So. Yeah, so if I run this now, it's creating these kind of green curves in Revit. But I don't know if you can create an adaptive component based on these curves, so you might then just have to start adding in Revit geometry off of these base curves. Okay. So the other question, though, on adaptive components was related to having multiple points, more than 4 points. Is that correct, or am I misunderstanding?
I had an issue creating, so in the generative model, I created the mentioned 4 adaptive points, even though there's a cross names. I created the square profile, and I created the form. So I have like So rather than volume shape like this.
Okay.
And then when I apply that to the surface, I end up with something really weird. Like, so when I click on the foundry, it shows up as it's like a regular square here, but over here it's not.
So you might not be defining the axis of your. So if you're defining this mullion here, I mean, you have to make sure that. Well, so if what I would suggest is like trying to flex your model, or essentially what is called when you sort of start changing these points. So if you start changing the points here, does it get all kind of wonky and crazy?
No, it's fine. It's just no, that's fine. Here, but for some reason they're not like joined. So over here it's a regular square, but when I'm over here it's not. So you have to this. You guys fantastic for I just look at the server.
Yeah.
Do you mind if I just add a question to your list?
Oh, not at all.
So, I guess we don't have to add structural matters that IMD panel, perhaps? Because obviously you did fashion panel to, like, for example, the slab. I was wondering if you could do like a simple example, an example of that, or
Okay.
just
I can do my best. I probably am not the best. You can either I can definitely give you a contact on Ian Kehoe on our team. He's done the most work with structural members. So so have you tried, say, just instantiating like an I-beam or something like that? Because again, you can create a beam in Dynamo fairly easily. So what?
I mean, I just have an idea.
Mhm.
Using space truss.
Okay.
That'll attach it, or let's say it's quadrilateral. There's a attach
Profile on that line.
and then me
So what we're going to do is
and then
we've got to
the slab will
actually
take the
put
weight
that
of the
with
panel.
its real.
Okay. Well, maybe we'll bring up an example then. This could be useful for a lot more people.
This time we need to know the path.
So even over here, you find
Okay.
The panel weight gets transferred all the way down to the
here,
Sure.
to this point. And this plane, over here, it's a little bit tricky. You got to get that plane. Because that's the plane that's perpendicular to the reference line. And then it will sort of stick to it. Because what's happening right now, we have the pieces are independent of the adaptive point, so the adaptive point is placed on the surface.
Hold on. Yeah, I'm bringing something up here.
So, what you can do here is get orbit this around a little bit. There's the plane. And now, all this is right now. But I want to be on that plane. Okay, and this other thing over here does have the same, right now, the perpendicular plane. There's a similar one over here. Although even here, I just go ahead and grab this and that one there. Actually, there, I'm getting close.
Oh, you didn't reference. Oh, I took I had two profiles.
No, well, that could actually work too if you want to sweep and have two different things. Let's see, so by doing it on the reference line, now what happens is, as this thing deforms, I have a stupid profile, so I have a reference profile. You can have a much more complicated profile. But you got to get it on the reference line so that it sticks. At least when it deforms, it'll kind of form.
So it's just that I shouldn't create the form from two parallel profiles. I should use one parallel, one profile.
It would work if you sort of define the profile and each of the different planes on the end of the input. We're just going to do by having a step. It's not, it wasn't sticking to the point right. Like, By doing it as a single profile, just doing the reference lines and going all around, it's really sweet. And that's why, it's deforming pretty well relative to the reshape, because the sweep is changing. So
Also, then, okay, and then it's even better to also
exactly. Although then we can think about, you could have this case where the top of the horizontals are going to be different than the verticals. So you can do that same principle. I did it on 4 reference lines. You could do it on each of the 4 reference lines and have a discrete profile on each of them. But the key is, you still want to have that sweep occur across the entire reference line from endpoint to endpoint. That way, no matter where the reference line gets formed to, by the adaptation, it will always cover the 4 reference lines. So, it's easy to go scroll all the way around, and you can't do that. Let me see here. I've got my profile there. Let's see if I can grab this. I'm going to get out. So now I just have a single reference line. And a single profile. So now if I do this, that'll give us a sweep on that one side. So you could go ahead and get different bars or different mullion shapes on each of the 14 sides. Feel is the same thing should happen over here. Since it's really defined across the whole reference line, as I go from the numerous line. So I keep on trying to move it there and it's to follow. The reference line is your friend. And it's going to generate more
But it's an issue he has a very complex profiles. And then you know, show them
that's not guaranteed anymore. That's where it's really
and also, I think this one profile, and it doesn't want to switch,
So to answer your question, yeah, it looks like the directory kind of moved around, so it took a while to open this thing up. But I found like this is a Revit structural framing example that should come with the Dynamo install that you've run. But I walk you through the kind of elements that are going here. So we have a house. Again, this is kind of contrived, but it works in any of these examples where you perhaps generated some reference curves in Dynamo, or you have them just as drawn on your form, or maybe they're an adaptive component. So we're selecting them here, selecting model elements, extracting the geometry, and then actually using something like point at parameter. We're generating code block to generate several. I guess I've got to run this just so you can see what's happening. Generating a set of parameters that we're then using curve point at parameter to sort of essentially generate points here on these 2 imported curves. Generating a line, flattening them, and then now we're actually using the structural framing by curve, level, up vector, and type. So this is kind of this is where I don't think Jordan is really asking you to like create levels on your model and actually go to that level of detail. So you shouldn't. I think if you can make a accurate claim about like here's a form and it has a certain material and it's oriented in a certain way, like and you have and it seems to make sense, or perhaps talk to him about how the load paths would flow through it. I think that might be a better route forward. But this is showing you how to make an actual structural component in Revit. So. I will imagine not, but again, if you know the profile and the material, like it's steel and it's box frame and it's this thickness, like you can find out the properties, the structural properties of those. But so looking at structural framing by curve up and level and up type, we can see that like here it's dropped in an actual kind of BIM structural frame. The type selected is looks like 1 by 34. I don't know. This looks like a composite, like wood. Yeah, plywood web joist. Okay, so it's a piece of plywood. We can of course change this to be something else. like this, and this is dependent on what you're actually loading into your family. So here, yeah, the circular metal beam is another type. So let's see. Yeah, it's just tubing. So these are all things that would exist. So you probably, I'm pretty sure you can instantiate these types without the structural framing node. But if not, then yeah, I would imagine that you actually can instantiate these without creating a level, but if not, you might have to sort of create a set of dummy levels, perhaps, like at the point of your either your mullion or your window frame.
So things, this one, things for a roof, right?
Mm-hmm.
Roof of that house. But I guess what I was thinking about in terms of structural covers is, if we're talking about the facade, which
Sure.
right? So how would that work out? Because we wouldn't use the same structural system.
Yeah. So yeah, similarly, if I just made a new, well, actually don't quite want to do that. So if I do structural column by curve, I hope this is a column type.
Something like a curve wall, that would be.
Let's go ahead and try this. Let's say instead of having this, go to curtain wall kind of base. Let's go just sort of generic. So let's go ahead and
Okay. So I think I know what you mean. So let's see if this worked out. I mean, similarly, okay, so this one does not want to do that.
Let's now go and say insert and move that profile again. I'm just going to go to this. I'm trying to get these
So I'm not, okay, so I'm able to sort of populate these columns here, but it doesn't seem to be, they're oriented in the wrong direction. As you can see, I've made a whole series of lines. I'm making a structural framing column by curve. So this is sort of the input. We have a curve, we have the level, I don't know, we can make it level 1 or whatever, but they're oriented in the wrong direction. So I'm thinking this might be a problem. Vertical, oh. This might be a problem with the actual property of the element. But I mean, this is essentially, I think this is a problem with the actual family that I'm instantiating, that essentially it's locked to be like horizontal, but this is essentially how you would instantiate a structural framing element. It's as straightforward as making a beam. You have an input curve that's the base form, and then you have to kind of specify a structural framing type. Also, this is completely locked in horizontal. Mm-hmm. Okay. Mm-hmm. Yeah, I should be able to.
In front of the line, because I'm not sure if I did everything correct,
Mm-hmm.
because I couldn't see.
Okay.
Thanks.
Mm-hmm.
This is why I'm asking.
Mm-hmm.
So this is inside of London City Hall.
Right.
Outside are the triangles, and you see these white numbers here.
Yeah.
That's basically the structural number that the weight is going to, and yeah.
Right. So I think let's. I can try one more time. Again, I don't think it's actually. So I think it should be as easy as kind of as advertised. So let's see if. Let's see, where is Dynamo? I can restart this. Yeah. Well, so you'll end up with a whole series of curves that you'll have in Dynamo, and then those will be used as sort of the base profile curves along the structural members. So I think at the moment we can get one that's vertical or curving. I'm 100% confident you can lay those out. Of course, like you'll still have to figure out what they are and find those families in Revit and implement them.
It just seems like this one looks like it's just offset. It's like I guess I'll come up
Here's what I should have done before.
So you can actually they don't have actually this seems like it's funny that it's different from offset so they're yeah, it's like triangles like this like
We are controlling it's really, and I think the profile is not as a profile.
Yeah, but not in the.
Okay.
Ultimately, the form has to be in terms of creating form. Ultimately, you need that control.
How much?
So you can actually generate.
So yeah, so to answer your question, again, it wasn't just simply an issue of I had selected the wrong type. So I had the wooden beams weren't sort of playing well with being like disoriented or kind of not oriented vertically. So this is just a way you can take any of the structural members in Revit that you have loaded into your family, and you'll select from it here, and then you'll input a curve. And if you want it to be slanted, or you can have it as vertical, or you can have it slightly slanted. So here I'm just making it more and more slanted. So yeah, you'd probably just want to either find the find that digrid form in curves on that kind of surface, or you can try making them curve form. I don't know if the backing family is going to support a curve type, but if it does, then you should be fine. Yeah, like a curve, curve column. The pipes might, but I don't know. I mean, we can even try. Well. Okay, this one does not. Try one more. Okay, so we're trying to make a curved column here. It doesn't look like it is working, and you might want to ask like a Revit guru or someone else who might know whether or not there are curved column types in Revit, but it doesn't look like it's working with the kind of standard ones we built for this suburban house or imported for this simple house. But that isn't necessarily a fundamental limitation.
So that example for the structural framing.
Mm-hmm. Yeah. Oh, you can. It should be in the samples help samples. I don't have that. This is a development build, but it would be under the samples. There's a Revit. You might even need to go to the Dynamo install location, but there's going to be in there eventually. Whoops. Say a Revit file called Dynamo sample, and the reason why you'd want to open up that file as opposed to other ones is that the element ID types are going to be linked. Mm-hmm. Okay. Maximum deviation from the input surface. I think I'm going to choose that before going on.
Okay, so the surface superlative, we have to get all points survey, adopted surface nothing else. So in that way, we have forms with this
Are you asking whether or not you need to use the like imported family surface or a SAT surface? You can use either. Oh, I mean, yeah, you'll want to use the surface that. I don't know why you'd want to. I mean, can you like why would you want to create your own surface? I would like to explore like forms, like different forms, or I think the only reason why he'd want to keep it to this surface is then he could take a look at your geometry and see how much it deviates from, like it gives a kind of baseline for him to tell how much your designs have changed from that initial form. That's my intuition. So, okay. Yeah, absolutely. Yeah, no, well, yeah.
So, long story short, I create multiple families, one family, 2, 3, 4, 5, and 6. So far, what you see is this piece, but a solid version. This part isn't hollow. Here. So the piece is this piece. So just a quick question. So I got it to come on the surface. Do you know? Do you have like some tips on how to deal with the overlap?
Okay, between the main edges.
Yeah. So for in this model, maybe there's a better way of doing it. I created a profile and I selected all the reference lines.
Mm-hmm.
I guess for you includes one line. But you also have corners to deal with. And a question that was asked earlier. Oops. I'm not sure if you answered it. How to get these to curve with the surface? Being flat.
Yeah, right. So I think there's basically two options for that. That's kind of what I was showing before. So one of them is to essentially kind of not have like the family itself model completely in Revit and model more of the geometry inside of Dynamo. So that would undo a lot of the work that you've already put into so far, which is the kind of unfortunate downside of that solution. The other one would be to say extract out. You can basically get the curvature at parameter, principal curvatures at parameter of or the Gaussian curvature at a surface, so you'd be able to extrapolate. You actually know how much it's curving along that surface, and you know how much that's going to bend. At the point? Yeah, at the point. Or one more option is you can create an adaptive component that takes in more input surfaces. So for instance, you can have your adaptive component, it takes in more input points. So if your adaptive component right now takes 4, well, you could add a sort of intermediate point, turn it into 8. Or you can turn it into, I don't know, 16 or 12, and then interpolate that surface. That curve in your adaptive component. Right now, you're basically saying you have, let's see, if I open up, it's just this simple opening. Here you only have, 4 points, and you're just drawing a line between it. There's nothing stopping you from passing in, like 4, 5, 6, 7, 8, 9 points here, and then interpolating between those. So yeah, I mean, there's basically many ways to do it. It's kind of you're just choosing what do you want to optimize. So if you really want to keep the family that you made there, I would probably say an easy route is basically extract the curvature and pass it in as a parameter that tells how much to curve. Perhaps like a more challenging route would be just to sort of pass in more adaptive component points and then fit a kind of a NURBS curve here or spline between them. You just do spline your points, like with this command here, instead of doing a straight loft there, and then you can curve with geometry, right? Or if you really want to go like one step beyond that, you can simply do what I was doing before, where you're actually getting a curve on the surface. You're basically saying I have start parameter and end parameter, and I'm going to get a kind of curve on the surface, or on that surface, geodesic on that surface. It's running along it.
Along the line?
Or along the surface itself. I think that's what I was showing just slightly before here. Basically, yeah, just right here. This curve by parameter pointed surface. So this is giving me a whole series of curves, and these curves are on the surface itself, and I'm specifying that by parameter points. So it's going to give you a curve that's like following the surface exactly. But the downside to that is it's harder to get that into the specifying, like putting that into the adaptive component. You're sort of limited to this in dynamo geometry. So like I'm saying, I'm just giving you a bunch of options there. I don't know which is the best one. It's going to depend on what you want to get out of it. So, but do most of those options seem clear? At the very least, you can, I would say, add more adaptive components. Like if you just add an adaptive component point there, 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 and there, you're just going to get a spline through those 3 points instead of just a straight line between 2, and that'll help.
So in terms of here, it wouldn't be a create form. It's still a create form, or
well, it depends how you set everything up.
here basically I drew a profile and I clicked the reference line and put create form.
Yeah.
Is there? So instead of doing a line, I do a.
Exactly. Yeah.
Do a.
So you do a spline.
Instead of a line.
Yeah. So like, I can take this. So I just made a spline, and I can, again, oops. I can select. Okay, I'm selecting. There we go. Okay, so I'm selecting a whole series of points on these splines. I can then say make adaptive on these, and it's just going to add these points right on there. So again, what you would probably want to do is for each one of these kind of perimeter curves here, you'd want to again do that. So you'd end up with like 1, 2, 3. So that, of course, that would require you to update your actual Dynamo script here. So you wouldn't be able to just use by quad points on face, because now you need 8 points to specify mullion, right? It needs to be sets of 3, like start, mid, end, start, mid, end, start, mid, end, start, mid, end. Or rather, no, it would be start, mid, end, mid, end, mid, end, mid.
Okay.
So I mean, it makes it more complicated. I mean, there isn't just a sort of a button that says make curves. I mean, again, if you wanted to try, like, without modifying that at all, you could try passing in this curvature of the surface and to try and distort it.
So here I'd add like a point in the middle.
Yeah.
It was always like height or offset.
Yeah, exactly. Yeah.
Curvature.
Okay. Hi. Yeah, absolutely. I think we sort of reverted into sort of like one-on-one mode.
Yeah, I'm just not sure. Okay, so I have my basically everything you just described, and my adaptive component is in here. But when I make changes in the Dynamo file, it's not changing anything in here. Is that what's supposed to happen, or is it supposed to move things around?
Yeah, I mean, ideally, it is supposed to move things around.
The family that's...
Okay, so you have. I'm just trying. I need to hide some of these just so you know what's going on.
Also, I'm not sure. That's the reason why I can't see the changes that I make in there.
Probably not. I'm just gonna and I'll probably just remove these notes because you know.
That one is to put it back into Revit, right? The one you just did, I think.
Is it?
I just figured out how to put it. I was having a lot of issues getting the surface into Dynamo.
Oh. I think that was a similar one from this. I think it was got a duplicate node there, but maybe I'm mistaken. So okay, so now we have okay, so you've done quad point space, and we have parameter point, all that sort of stuff.
I put that as my window.
Family 1 to 2. Okay, I'm just gonna confirm this is okay. So that's that. Maybe I'll quickly. Okay, looks good. So if I had to guess, it looks like everything's working here. This is Reddit.
I used more.
And also, changes you make in Revit to the sand pane show up in there, and then the only thing that's really pulling into Dynamo is the corner points that you made active adaptive components.
Well, this should be working, which makes me wonder whether or not. I can save this, right? Dynamo surface. Okay. Try closing this. I'll just make a new project. Architectural. Is this the same one you had before?
This one's window. The other one's family.
This is okay. Yeah, load in the project. Just to make sure everything works. Okay, look, everything seems to be working fine there. So let's start it down one more time.
I had it in the Revit file for the project.
It could have. I mean, sometimes I'll admit, like if you have run automatically on, it sometimes it can be problematic with linking to Reddit. And this has to do with just like that's essentially the reason why. That's the reason why it was actually put in initially. Is that like when you're using Grasshopper and Rhino, which is another kind of tool, it does everything. It's always run automatically, but because Revit has this sort of lag to it, it just get in a weird state. So I would probably just not work with run automatically on for the time being. This is yeah. So it was basically. It looks like something. You just had to sort of kind of close down the project and reopen it.
Okay.
Yeah.
If I make changes to the adaptive component, it'll show up. It'll go to Dynamo and go back to Revit, basically.
If you make changes to Dynamo, so in other words, you're saying if you like
I'd say I'm in a family and living.
Oh, okay.
Changing the component.
That should work. I mean, let's just like verify it. So this is.
I haven't made anything of this one yet.
Is this?
Supposed to be inset.
Did you? Okay, you did have the inset. So I think if we do 5 here, 5 project. I think so. Yeah. So if we look here, I think they're slightly thicker. That's one more time to confirm, but yeah. Okay, it doesn't look like it did update, unfortunately. So, I mean, like, in other words, the property did not update. If not, I guess that's sort of, yeah, you might just have to sort of reflow it, yeah, on it. But I mean, it shouldn't matter because it only took a second to sort of recreate the family.
And then the back part you just do through another bunch of dynamo commands.
I would probably, so you have this surface, which I think was like number 3 here. And in your dynamo graph, I think it's identical. I would probably just, oops. I mean, the only issue is that they look like they're separate curves with kind of different forms. So this one, yeah, you're going to probably want to come up with a different way to, yeah. But so again, you can still do quad points on face, but you know, you want to change the settings so that there's not 10 of them there.
Okay. Okay. Thank you.
Yeah, no problem.
And then have this glass where still
the deviation? Yeah, sure. I will. It'll probably take me like a minute or so to whip up an example. But yeah, I'll probably show the class then when I get together.
They'll just say that.
So it's a lot of curves, which is really the placement point. You're going to place your volume at 7 pounds. You're going to place pounds in there. Even in Henry's pounds, you can go through and relative to the placement points, define the representative stands off relative to that. And then this camera inside. It doesn't have
Hey.
I was wondering about this house. So now our roof is like
Because they give us.
square
Okay.
instead of
So you're going to grow the outside.
how do I approach that?
Yeah, so are you just using, yeah, you're using pointer parameter on this, let's see, so you're taking, is it, so you have this one right here. And you're using what, like quad points on face on this surface?
On the roof.
On the roof.
Yes.
Okay, and so the problem is that, okay. Maybe I'm going to explain this to the class really quickly. What's going on here? Yeah. So I just want to, hey guys, if anyone is curious, I'm just going to quickly explain what's going on. Someone else asked me about this today, sorry, last week. And someone else again asked me today what's going on in this situation. And it simply has to do with that's our geometry library. Essentially, is essentially boundary representation, where you start out with a very primitive surface, like a patch, a fairly straightforward surface, and you trim off the parts that you don't want. So even though this looks like it's a circle, it's actually on the back of it. It's actually represented by a square patch, which is kind of obvious from the point of parameter. It's not that the points of parameter indicate that it's sort of extending beyond this circle. And this is sort of a fundamental limitation of our geometry library. So there's not much we can do about this here. What you might want to end up doing is well, let me try and come up with a quick solution around this. But otherwise, I just want to let you guys know that this isn't really a bug, but yeah, it is going to be something that we're going to have to work around. Okay, so here's my kind of workaround, my quick workaround for how you can start to think about these top surfaces that have weird parameter space. So it looked like initially I tried to extract out the perimeter curve and rebuild it, but it didn't look like that was going to work either. Essentially, yeah, the underlying geometry kernel wasn't accepting that geometry. And by the way, this is kind of a larger problem in most CAD applications where if you have these kind of trimmed surfaces, parameterizing it can be very difficult. So instead what I've done is created a series of planes. Here they're not represented, they're probably just hidden below in this form. Actually no, you can see them down here. We have a series of planes. I'm using those to intersect this top surface at a whole series of points. Or in a series of lines. And then I'm extracting out the points at parameter on these curves. So it's similar to what we were doing before, where we're getting a whole series of points that we can then turn into quads. But these ones are now fitting more precisely onto the surface itself, and they actually have the same number of points here as well. In other words, you're not gonna have to move beyond simply kind of using a quad point on face. You're probably gonna have to sort of build up those points yourselves and then turn those into quads. So I can show you that relates. I think this actually dovetails into sort of list management. So why don't I put together an example of sort of how we can go from these sets of points perhaps into quads, or somehow change essentially do list manipulation on this otherwise really long list of points.
So what would be the simplest process right now? We would practically
Oh yeah. Oh, absolutely, yeah.
So is that why you use the Python to something that would grab the points at each part and then like establish, say, like an actual interval at 0, flip at y equals 0 for all the points, and like grab the endpoint.
I mean, you could do that in Python. I mean, yeah, it's Python. If you know how to use arrays in Python, it's going to take your Dynamo work a lot farther. Just because you can start to manipulate arrays a lot better. I'm trying to figure out a way to do this without going to Python. I don't think I'll probably be able to do that, so I'll probably just share that Python node with you, and then maybe ask around our team, because it seems like it's a fairly complicated list structure. As you can see here, the really weird cases get where it's a nested list where each one of these elements is, there's a list that only has one element in each one of it, and so just kind of making sense of this is difficult. And then there's a bunch of empty elements. Sorry.
Okay, but like Dynamo has like functions that let you do like similar lists.
In node forms. Oh, sorry.
Like so you can like grab the nodes and grab like all the positions from
Oh, so are you saying that like if I have a point here, something, or I have a set of points in a list, and I do something like point dot getting the x parameter. Are you talking about sort of the fact that it's sort of essentially the properties of the object are being extracted out of the list? Or okay, yeah, I mean that will work in Dynamo. Yeah, as you can see here. So.
And then you can link that to say if you wanted to manipulate the x of like the next row of those dots, you could grab the information from that bottom, that like initial list, and say like all those like -1, and then you can switch the.
You're gonna want to make sure that there aren't like because if there's nodes that are dependent on a kind of previous node, it's going to have to execute before it gets to the next step. But I mean, if what you're saying is that, you know, here, okay, that's weird. If I, for instance, have, oops.
What I'm saying is that like right now, the way that everything is right here, everything's like a nice rectangle and everything's like distributed evenly, like along that like plane. But if I was on the bottom of this right here, and say I wanted to make each of these spaces on this fattest side, like whatever this was, I wanted to come down like by y, by like y equals 1, like I want to make this come down by y equals 2. Mm-hmm. Would that be possible?
Yeah, certainly. I mean, so for instance, so let's say we have this, I can just delete these here. So, and this might be easier to see. Maybe I'll.
I'm just thinking because like the way that we're trying to do it right now is that we have a bunch of panels like this, and instead of trying to manipulate these panels in Revit to make them different, if we could manipulate the panels in Dynamo,
yeah,
so that when Revit puts them in, they'll already be sorted.
Yeah, well, it sounds like what you're saying is like, so if we have a series of geometry, and you can still feed in, like if I want to translate this, again, I can almost pass in a very similar number as I had before. So here I have a list of 10 points, and they're all going on the keypad. Here I'm having translate, and I'm passing a similar list. It'll just map one to the next. So the first one, this list goes from 0 to 10, and then so the first one's going to be translated to 0. The next one 1, 2, 3, yada yada yada. So basically, you'd want to do the exact same thing. Yeah. You'd pass in that if you know how many elements you have. You have 10 window segments. You just pass in a list of 10 elements, and it's gonna. And these 10 elements can either be sequential, like 0 to 10, going up by 1, or they could be kind of more interesting, like a sine wave or.
Yeah, or like if I put in like 10 ones in there, or like just put in a 1, then each one of these dots would be translated down 1, 0. Like it would be translated down, well, instead of like ending up in this line.
Yeah, you could just do -1 at that point, and then it's just going to translate everything down 1. So if you pass in the list, it'll map the elements of the list together, and then if you exactly. If you pass in a list and they match up fine, then it'll do 1-to-1 mapping. But if you pass in a single item, it'll just apply them all, apply that one element to them all.
Okay.
Yeah. Mm-hmm.
just install first.
So you get the spline.
This would be.
And then that's now. So what is it? How does it interpolate from the difference? Because usually when you place the
What you're trying to show is these parts here. You have these parts here.
Oh. You do it again. So you need 9 points. So what you need to do is keep it that handle. Right? You place 9 points and you repeat that. Then you actually do all 9. So what you need to Dynamo is in the same way you have quads, you need a function. It's a mathematical function. How to go through and create 9 points. How do you instead of a quad, like a non-F, or whatever you call a 9-point surface? I like this. It's almost like this takes 9 points and this is 6. Okay, so when you do quad, somehow you figure out, given these X and Y, you figure out how to go. Okay. What you want to do is figure out how to go. Grab all 9 of those points. Okay, and then skip over. So what you want to work the trick comes out of actually given X, Y, 0. How to go through and get points 1, 2, 3, 6, 7, 8, 10, 11, 12. And how to simplify that is to get those. As soon as you create these collections in 9 points, it's like we create collections for us. We can place them in so we have oh no, there's many problems to it.
Yes, you and more points. But
Exactly, because once you're within there, on that surface, you gotta avoid that. For example, you can do different things.
Can you just put inside of class?
This is clever. I didn't really think about it this way. I understand what's going on. That's actually pretty nice. It's really so what that means is, in order to really follow the curve closely, your panel stretches over more frames. Okay.
I understand,
Yeah, now he's putting it more down. So because he's applying the manual. Now this will live in the next.
That's what that
Oh no, that's all fine too. That's all fine too in terms of doing that. No, this is that part is that's the same whether it's a 4 point or a 9 point.
no, I've been fighting this.
Oh, not at all. Yeah, that's actually part of the reason why I'm writing a Python script. Is like I was trying really hard to think of how I could do it. It's a kind of funky list here. It's like a bunch of single points and sublists, and then an empty list. So I'll just share this.
It's a good one.
So it's not like a much better job. And it may not be an issue, but
Prune duplicates. I'm looking at this guy here, but this is a point. This is based on points.
I can actually.
No.
Okay, that's good.
So you said you can feel that anything. Yeah.
No. We'd have to get into, it's not in a standard mode. And actually, Patrick, do you know, like, in terms of Dynamo being able to control, can you, like, do the divided surface? Can you drive what it does in the Revit interface through Dynamo in terms of, like, choosing the form and dividing the surface? Or is it really you're getting back to the primitives?
So in other words, can you drive like UI operations or like?
Because it's easy
Okay.
UI. I'm encouraging a lot of this to get started. Just okay, let's just take surfaces and try dividing them in the standard Revit way.
Yeah.
And applying panels because you sort of do a lot of exploration for you from that.
The short answer is the only stuff that's exposed is in this sort of Revit, the list of Revit things on the side here, the nodes that we've exposed, which is relatively little. Yeah, I think, but yeah, because the proposed workflows, you bring the geometry, you process it, and then you output it out. You might be able to get around it by kind of working with it in the Python API. Yeah, that's what they're doing. Yeah, where you get into the Revit API through Python, which is like kind of, yeah, that's advanced stuff.
Yeah, it's good. It's amazing how far they've gotten just by plugging into it that way.
Yeah.
You really get to the guts pretty quickly.
Yeah.
Okay.
Well, it's not necessarily a good thing, but you know. Yeah.
Okay, excellent. So the short answer is it's not easy. Yes, there is. But to do it in terms of really, Dr. Henry, in terms of he's done a lot of work in terms of trying to use Python to drive the Revit API. It's not an easily exposed node, but if you did, you might be able to get into it. But I think maybe you do that like this. Yeah, on this face. I think this notion of really trying to come up with a mathematical way of taking that grid and choosing the 9 points. Yeah, we thought about this as a math problem and sort of figured it out. And it has slightly different increments. But the same basic logic that lets you choose 4 points, lets you choose 9 points. So a little hopping around. I think it's the same sort of logic. And that would be very generalizable in terms of this curve. Later on, if you want even at 9 points, you do a pretty good job of approximation. Maybe later on you want to have 16 points. Even 4 points is flat, 9 points is marginally curved. The more points would include a better job of doing conformity. So I think you're on a good strategy. Yeah.
So or is this like taking into account the fact that like it may be curved?
Actually, it's an interesting thing. I think you have a really good interesting issue about this thing. Yeah. If there's a placement point and there's some line with panels and even there, as you're drawing the idea of standing off on the side, extending beyond, and then standing off on this side. Yeah. You can do that in terms of the left side of the panel and the top side of the panel.
So, yeah, to answer your question, I'll share this. This is a good showing. We sort of parameterize that top surface and still lay the adaptive components on the top of it. It is possible, it just requires a bit of work and a Python script, so I'll share this all with you guys. Hopefully it'll help you guys move forward.
Point and extrude them, and what's great for flat surfaces, but extruding, what happens is that extrudes up, that extrudes up, and you have these gaps. So typically you get this gap here, slot through there, and do that. So what you want to do is, when you bring things up, as opposed to extruding, as opposed to being a straight extrude in a normal, what you want to do is actually have a point which is normal. So you have a point here, now there's a point there. And then that gives point, and that gives your little tabby thing. It's just a little tabby thing. It almost moves like a ball.
You can try it if
Yeah, to get the geometry right. It's all action or something like that to do that. But you gotta basically define everything in terms of carefully like stretching up as opposed to extruding out. Oh, exactly. If you extrude it just off of the plane, it's still extruded off of here. You're going to end up with that funny gap. So what you gotta do is extrude it perfectly.
Yeah, absolutely. So basically, all corners work except for this corner. Like when I want to drag this corner out. Yeah, whatever. When I drag this one out, I don't know why the line doesn't like connect to this point.
Huh, I'm having a hard time figuring out like where some of these elements are coming from. I mean, maybe I can try driving, but like it's just kind of hard to tell like where, like how you created these forms. Okay, so this is this is an inset point.
Yeah, this is an inset point along this line.
Okay, and then this is another. Okay, and this is another inset point. Okay, and then these forms. These are like a solid form that you're creating.
These are extrusions. Solid extrusion. So I don't know why all my points work except for this form. I don't know why the line doesn't join when I meant to join.
Okay, so this is if I move this. I'm curious to know what happens if you move it out of plane.
If we take all that and let's say create a form, which is the way we typically do, that actually makes something that's perpendicular.
Okay, I mean, so which one? How can you break it again one more time? Like
so basically, I mean, the original idea is that it's controlled by these four adaptive points, and then like they are joined by they're joined by a reference line. So this point is along one of the diagonal reference line, and this will control the width of.
And so this one isn't changing, or
I don't know. This one's supposed to join to this one. Is there any way to just join that? Or must I? Because I tried to recreate a game, but I'm just having so much issues with recreating mine.
Well, this okay. So this point, I don't. I think the problem is that this point isn't. It's not connected to this one. So like this line. So if I hover over this line, it goes from adaptive point, whatever it is, 4 to adaptive point 2.
Yeah.
But if I hover over this line, it's just going to nowhere. Well, actually, kind of. It's going through point 1.
This is to control the apex.
Okay, sure. Well, then I guess I'm wondering those, like how, like, it seems like you want like this.
This point, so I do change that. Is that
Yeah, it seems like this point instead should be like inset off of here. Like in other words, you should make a point on here.
Exactly, all the time. I want the point to always be perpendicular.
But this point is driving outwards. It's driving like
Exactly.
this point is driving like in the diagonal. At this point, this line is driving to create this slanted shape. So I don't think should that.
Yeah. So sort of like how do you rejoin up?
Is then we can rejoin this to one of the adaptive point.
I mean, you might just have to redraw it. No, I mean not the whole thing, but like, I mean, you should be able to get it to snap to the adaptive point. Change the scale. Maybe that'll help. No, it's making things worse. You do know the tab keys were used to kind of get in between elements.
I'll make an instance variable, that way we can change it on down basis. We're going to do the same thing with some of the other points.
Do you know about like temporary hide isolate?
Pardon?
So like I can select one of these guys and
hide it.
Hide element. I think it. Oops. Shit.
Here, and the nice thing is, if you do 4 of those, what's going to happen is,
This one helps there.
the penalty forms, those points will always be perpendicular to that.
Okay. Basically, we can
Start with a point, and then make sure I use the thick side.
So, yeah.
Even when I draw a line, is there any need to force the point to reference to any line?
I think there's I think basically okay part of the problem here is unfortunately you're working on a Retina MacBook Pro. You see, you can see like the Revit icon is kind of really small. I've noticed that like if I run on that's a part of the reason why I use Parallels is if I run on Retina MacBook and I'm not an external monitor, it just it's really hard to model in. So yeah, you might just I would just recommend using an external monitor. But I'm not even like it's just not.
Is it cost the 3D snapping off?
Maybe. I mean, that really shouldn't matter, but I don't think because you're just snapping to this point. Yeah.
Maybe I'm not. Maybe I should go check. Maybe I can error the 2 weeks of
Yeah, to be honest, I actually think like this is a weird problem where like if you could plug in an external monitor, maybe one of these external monitors, and like reboot, like I can take a look at this again. That's okay. I actually like it sounds kind of weird, but I actually think the problem here is simply that like I can't actually view the points because it's or even yeah, sure, work on one of those machines. Yeah. Okay. Hey.
So I managed to get my channel onto the circus, but if you see how some of them are like indies and some of them are outies, I'm not really causing that. Like I don't.
These ones are actually doing really good.
Like I'd like to control it so I know which ones are going in and which ones are going out, but I'm not really sure why. That's kind of random. You can like click on it.
I'm having trouble. Is there a trick to getting this panning on your mouse?
No, I don't know why you're trying to like rotate around.
Or pan, yeah, would also work.
Oh, pan is just the center.
Oh, the center. Oh, I was pressing down on the wheel. Okay, that's a lot easier. So how are you deriving these lines here?
I made a surface in Rhino and then traced that.
Okay, but I mean, like, are you just like, where are these points coming from? Like this one in here.
So that was like the max, like my surface from Rhino. That was the max point, like the most close I wanted it to be.
Okay.
So my parameter is essentially just like segment length along this. So if I change it, it goes like up towards that, which is the max.
And okay, and this. I guess because I think this seems like a geometric issue, but I'm trying to figure out where that bug might be in here. Like in other words, the geometry that you've laid it out. It seems like that's what's kind of causing it to be an innie in some places and outie in other places. Like just the interaction of how these lines are being projected in your family would be my guess.
I think you may be okay. You have points on top of points. That's okay if they hook together.
But I can't. It just seems to be like rhyme or reason to where they're.
Like ideally, that was like my idea is that my way down the building, I can control if they're going in or out.
I mean, have you been able to sort of get it to pop as to be like innie or outie just by flexing the model here?
It's all outie.
Even sort of fill on the sides and make a panel of thickness.
And do you have any you're not? There's no parameters that you're also working with.
Yeah, the parameter is just the segment length. It's pretty much kind of regular.
So using that same sort of logic, that's how we get to that point and that point. So now you still have to go through and somewhere in here come up with this keyway. And you think about that keyway. It might seem easy to go through. You might want
And like, so when are you saying that in this family there's an embedded or imported Rhino form?
I just imported like a sat geometry, and I deleted it.
Okay, you deleted
I just used it to get reference lines.
So there's like this isn't like being like rotated up or
No,
it's like literally
it's
just being
just
imported.
those lines and then like.
Honestly, I mean, so normally there's like a kind of parametric relationship between all the objects in the family. Like, in other words, you have these 2 points, and that defines like an angle between them, or like the 3 points would be co-planar, and then you can like tilt up from there.
That's what I tried to do, but like because there were so many lots of geometries in order to keep like these 4 planars, so you could actually build it.
Yeah.
This is like the simplest way. I had some other iterations where I tried to just like do like width and length parameters and do it that way.
I mean, kind of.
This is the most customized.
It's sort of. I mean, it works and looks interesting to me, but that's probably not. Doesn't make you feel any better. Well,
I'd like to control it. That's the main thing.
Right, of course. Yeah. So, but like, my guess is like, so when these families are being instantiated in like a kind of odd position, like these are either staying constant, or like in other words, if Rabbit is basically just instantiating like plugging into these points, and and then like if these don't necessarily relate besides perhaps like being built off that point, like I mean if you basically haven't parameterized them at all, how can it be placed at all? Like it might just be placed in world coordinate space in the family. is my hunch.
So how could I like just add like a parameter to this to just kind of limit the direction that it's going in?
I mean, like if it's, this might sound like way too simple, but okay, so you have a, I mean, I can draw it. Okay, let me try, like if you have, if this is your base and with your adaptive components points here, I mean, I would say what happens if you just draw a line across here, get like a point halfway through, translate it up, and then get another point, and then have that as your like your kind of green lines that are all heading up here. Like you're basically making a pyramid, and then you're getting these points here are just sort of points along that pyramid. But the thing about this is that you've now defined it precisely in terms of like it's always going to be like you put in a bit more work, but like because you can still generate these same points.
You can add more reference lines to
or am I, or
No,
that would oversimplify the form, or
I think so. Like that was the like this was the Rhino.
You have the session 5 fix on this form. Open up that one and go to the one called aperture. Oh no.
I mean, yeah, it's like a custom geometry. I just wanted to like.
Go to like session 5.
Okay. I mean, well, that's not to say that you couldn't. Okay.
But I could, I guess.
I guess I'm saying if you're just importing the geometry, it's my guess is you have no control then over like how it's going to end up in world coordinate system when it's actually instantiated on the object itself. At least my hunch, but because there's nothing looking at it like there's no way of looking at it to tell like how those lines are being distorted. Again, I haven't seen it really break or flip when you are moving the kind of control points around when you're flexing the model. So I'd be curious to know, just try that a few more times, like seeing how, so if you move the adaptive points on the bottom, like just around.
Yeah, so like these corner ones were like candy manufactured.
Like it seems like these points are always staying the same world coordinate space. Like they're always. So if you kind of flex it, it's still going to make that pyramid form, but just it's always going to try and connect to those points.
Oh, I see what you're saying. So
I'm because like the only thing you do, well, we can do that, but like.
So you're saying if I do what you're doing, like those 4 points, or these guys? You're saying
because these 4 top points, I like no matter what I do, it's like so if I move this over a bunch, like none of these top points are moving. Like there's nothing I can do to like get these top points to change. So it's like they're just kind of ending up. So even if I flip it over, they're still just the exact same position. They're just like imported. And this is what happens kind of behind the scenes with Dynamo when you are creating a reference point. Like you can take a Dynamo point and drop it into Revit, but it's just going to appear out of nowhere, and that can be a bit of a problem. So I don't know. I mean, my guess is like you just need, you want to get a bit more control over it. You could.
But I tried making these adaptive, and then my parameters no longer work.
Well, you probably wouldn't want it to keep them adaptive. I mean, again, my guess would be you want to do. Okay, so that's
like what you want.
Well, I mean, so if you have like a reference plane, create with an RP or something. I mean, essentially, you want to. I'm kind of rusty on my Revit, but because basically, if you create your plane here, that's not what I want. I mean, it's interesting. Yeah, no, I know. But essentially, what you want to do is essentially
You're saying a vertical plane, right?
yeah, or make like a horizontal plane or anything, and then even if you just took these like as like a kind of base parameter plane, like you took these 4 points and created a plane through them, or even took 3 points and took them as the base plane, and then you just made these points on that plane, and then sort of say like take the centroid of the plane. So like you have your four points here. They define a plane. Like if this kind of implicitly defines like a kind of center point here, or center like XYZ coordinates, you could really just sort of start. You can even just place those 4 points in there, like even randomly. You can basically say, all right, I want to sort of place these 4 points here, and then this plane, of course, is a normal, so you just want to translate them up. It's like really simple math, or even this wouldn't be hard to do in Revit. I'm just kind of rusty on sort of how to lay down that plane.
Yeah.
But then you still would end up with 4 points in space. But the key thing is that like if they're always going to stay in that plane defined by these 3 points on the perimeter, so it'll alleviate the flipping. So this whole thing tilts up.
So
They're still going to be
you're saying
facing
like,
outward.
look at it in section. You're saying create a reference plane like that, and then put the
Yes.
points on there.
Yeah, exactly.
So that they're
Well,
locked.
Yeah, or I mean, I would probably, you could also do sort of, you can create a point on this line, and then you also then would want to, how do you essentially now want to translate it upward. Okay, set work plane.
No, this is a challenge for all of us right now. Nancy's done a really good
There
video
we go.
that
This is what I wanted to do.
shows,
So basically,
taking a 90
yeah, this is what I was trying to say. So I'm defining like a reference plane. I'm using these lines define a reference line, and this point defines a reference plane. You can sort of see it as they orbit around. This point is kind of constrained into that plane. It has its own sort of XYZ. You can see as I move this around, it's always going to be in that plane.
Yeah, it's gonna be on that.
Exactly. Actually, I think I've moved it out of plane because but now it's sort of relative to that position. But the key thing is that like as I flex this and move it outwards, that's all going to stay consistent. So I would say is just like literally do the exact same thing. Like you make some points here, another one there, that defines 4 planes, and then now the key thing is to hit the set button, and then you just would need to sort of get that guy. It kind of takes a bit of And now when I create a new point, it's going to be in that plane. You can see the whole plane highlighted. And then ditto here, set point, and
Because
literally
really, like
anywhere.
my Rhino's geometry doesn't matter because it's going to change changing anything.
Exactly. And so now, yes, set, boom. And this pretty much now this should react a lot better.
Okay, and so, but now my issue is going to be it's only going to go in the positive direction. So, because I eventually want to create like a slider or something where there's like a range of variables. So it's going to go from like it can go from all the way in to all the way out. So does that just mean I need to create that long of a?
You see, I mean, one thing there's a few things. I mean, so again, there's a lot of things you can start to play with here. Like for instance, this has an offset right on the curve. Like it, so that's going to sort of change the sort of how far it moves in or out from this. So that's something you can sort of play around with. Same with this as an offset. So if I want to have this move 1 foot away from the plane or more, I can also then basically control. It's essentially setting up its own sort of coordinate system, but it's not an arbitrary world coordinate system. It's basically based on the actual family.
Can you put in negative values for?
Oh yeah, of course, yeah. I mean,
it can't because my curve doesn't go below that reference point. But if it did, if I put in negative, those points would go down. Like I can create the inverse of it.
I think the only thing that you might run into a problem with is like negative parameter space. So this is 0.3. Yeah. So if it's hosted on a curve, you can't do that. But here what I've done is this is hosted on a plane. So I mean, again, you can. So okay, another way. Okay, this was another thing. The other way to do this that's even simpler is you set this as the work plane, one of these guys. Okay, then you draw it on here. And then now I can move it around here. This is kind of what I was saying before. It's even simpler. And then it still also has an offset that could be like 5 feet. And apply, and now it's in 3D space. But again, like what I want you to just observe this is that like as I'm moving this around, like the whole thing is moving with it. Like all these points. Like if I move this up, like the very nature of the plane is changing. Like because now it's like that. Now they're getting offset in that direction. So I mean, yeah, I think you can achieve because the forms are so simple. So yeah, but looks good. Pretty good. I think the only other question that we kind of haven't gotten to is getting the deflection, essentially the deviation from the inverse surface. But yeah.
Okay. I got a couple of questions about the curve panels. Did you ever get any questions? I don't know I'm saying. I don't want to hold you, but do you have any? Maybe email you about the curve panels?
Yeah, I think I proposed there's like several solutions to that, but I mean I was describing it. Maybe just doing it individually, but maybe I'll just whip up a quick example now. I think that actually is probably easier. I mean, so because essentially why don't I just whip up? Yeah. Oh, I mean, because basically like as I was describing before, to someone else appears was that you really just are adding another like middle point here. So instead of having this defined by 4 points, it's going to be 8 points, and then that'll define like a kind of spline curve. Yeah. Oh, the curve. Okay. Yeah. But do you? I think the circle. I showed this example. I don't know if you saw this. So adaptive components on the top surface.
We waiting for the. I don't think I can do it now. I need to do my other one. Yeah. I really like nothing one. But I will just offset the color.
So yeah, I mean this one. If I'm going to share this with everyone here, but yeah, the parameterization of the top surface is kind of weird, but you can get it to work, and this is the workaround that I found.
It's internet generated process, I think, or something.
I don't know. It's not working. Oh, there we go. Cool. Something that's really, you can't, when you control tab, it doesn't go to the Dynamo window. This is so weird. Okay, so anyway, what's going on here is we have our top surface, and as you were mentioning before, it's kind of makes a square. So I've defined a series of planes on the bottom here. You can see them. Let's work around. So these kind of square things are planes, just kind of arranged in space. And it's kind of like an egg cutter, right? I'm just intersecting them with this top surface.
Okay.
The intersection creates a series of lines. Just like, makes sense. And then I just did curve at parameter, or point at parameter here, with a whole series of parameters.
Okay.
And the only thing that's kind of tricky is I had to write this Python script that I'll send this out. But this is essentially taking this flattened list of points, because this has kind of really weird. It's a pretty weird list.
Okay.
And so I'm flattening it and getting a whole series of points, and then I'm turning that into a whole series of quads. So, but once I have that, then, and if you don't know a Python, or you know someone around here who does, that might help also tremendously, or you can sort of like get a sense of what's going on inside that script. But yeah, then once we have the whole series of points, then we can sort of map it on here. Now you can modify this to however you want, but this is the way you can sort of start to work with the top surface. Okay, that makes sense. Okay.
Wait.
You don't seem too lost, but
So,
okay.
So the planes will intersect with these.
Yeah.
Little points.
Well,
You have to.
so the intersection, the intersection between a surface and a plane, or really any two surfaces, is a curve, right? So this just creates a series of curves. Well, actually lines.
Oh, gotcha.
Because it's a planar surface, and the plane is planar. So a planar surface and a plane will always make a straight line. And then now we get the curve point at parameter. It's an unfortunate workaround, but like I said, this is a standard problem even in like professional offices or with different CAD programs. Like parameterization can be difficult. So yeah.
So the corners like over here are gonna be.
Well, so I mean, I would, if I was you, I would probably build off this example and not just take this.
Okay.
I think if you took this, that would be like as 0 to, or Jordan describing like a 1 out of 10. But yeah, you're going to want to try and figure out how you resolve this. I mean, one option that I think is reasonable is to simply say like, that you're going to have a different kind of patterning geometry on the top than on the sides. If you look at the actual City Hall building, it's not seamless between the top. It does look kind of different on it. So I wouldn't necessarily try to say, all right, you have this window system, and it's on the exterior. Maybe come up with a slightly different window system that just looks or works in some sort of synergy between the two. In terms of the point numbers, what you might want to do, even if I were to take these planes, let's see.
So this one.
So I'm just creating a whole series of like planes in the other direction. Another way would be to say I'm going to have these curves and essentially intersect these together.
Wait, what are you intersecting then?
Essentially these curves that I've gone here and a whole series of additional planes. So if I actually like hide this. Really? Oh. So this is kind of a slightly different way to do a very similar thing. Basically, as you noticed before, when we did this point at parameter, I guess I can sort of I'll reveal these and then alternate between the two. It's kind of hard to see, but like in this one, as we get near the edges, the points are kind of collapsing together. They're kind of squishing.
Yeah.
Which is sort of less than desirable. So I guess what I might propose otherwise is again, you can do on the same logic is sort of start intersecting planes together with curves, and you can actually start to get like a square grid on the top area. So again, like I was saying, I would probably take this as a kind of a base and try and work with it and see what kind of works with your geometry and you like the form, etc. And this is just should be a point of departure for your work, and I hope it helps. Yeah.
Thank you.
No problem.
I just do a concrete plate off the roof.
Yeah, right. Simple slab. Why not? What was it? The example was curved adaptive component. So yeah,
If you already went over that, I don't want to. But can we get all your Dynamo scripts?
Yeah, absolutely. Yeah, I mean, is there? Because if I give it to you tonight, would you be able to send it out to everyone? Yeah, I'll do that before I leave then. Yeah.
Thanks. I'm going to kind of wrap it up then.
Yeah, I mean, if I can try and make one more adaptive component that's curved, but I mean, it might take a while. But yeah, if that's not a super pressing issue to make this curved adaptive component, then yeah, I'm fine wrapping it up.
Well, like you said, I don't want to keep you here all night.
Okay. Yeah, I'll give it another shot and yeah, try and present it.
Since 8 o'clock, so everyone has to leave, but Patrick is going to work out the curve panel a little bit, and we'll post all his Dynamo scripts, and we'll post the recording. And unfortunately, Forrest and Jordan didn't make it, but I'm sure they'll give you feedback in your sketches tomorrow. I'll be able to do it tonight. I won't edit it. It'll just be the whole thing. But
Sure. Yeah. But in terms of
Okay, so we should be able to it's like the way that being taller, like that sounds like so like as long as we set up components so that like the standard
Oh, sorry. Okay. Yeah. Give me when I finish with this, I'll come over there.
and if you want to create another offset, and then offset and then define the edge and moment by that distance. So there's 2 lines of that. That is really right at the point of the intersection or the going back. So if you want to have like a mullion that is off or a candle that is off, etc. What you got to do is you put another point on top of that, and then the offset is that same parameter go through, and then you draw the edge of the frame to those interior points, not present points. That's what I did the reality is this is different from for example, if I wanted to be above this point, but to say, so take that plane, put that on top, and then if I choose that point, with a all concept. Like, really cool there. And now what happens is, if I move something down, relative to that point.
So it's wrong pole.
The same sort of things feature that you say, you want to go through and go. Jordan's not like that. Didn't want to do that. They like this. I don't know. They like this. It's challenging. I want to see it. I appreciate in front of it. So now, so what you want to do is it's almost like you have to do it 2 steps at a time. Off of one plane and off the other plane. Exactly. So in the same sense, okay, so here, when you do minus one, now that point forward. This one,
Keep up the good work.
So the answer to what you want to do is you basically we want to have an inside or outside. And basically, if I do 4 of those on each corners, then I would have now what is all smaller spacer balls, or in this case even. This is glass, and this is configuration, and this is on the other side. So if you want to keep them outside, if you want to the outside, if you want to do the inside, which one do you do? Oops. Oh, sorry, that's one way to get exactly. Yeah, no, that's like a frame on the panel, and then you have this other thing where as the frame that the joint. The way to do that now we can work with it here, okay, because you got that kind of before. You don't need to use another series on the inside. What you can do now is you can say that you want to explicitly do all four and you can have movies different size. You can go up here and then we look at these devices. Then now draw my frame like that, and then sweep that frame over. That way, even here, you control this. Like basically, makes a frame of the. How do you do what happens is reference points or reference lines. Let's make sure that's actually proper. It's always hard to see. Oh, I said yeah, so it wasn't. That's why I didn't do it, because it was all actually working. That's what we did. So it's hard to draw.
Yeah. Or do we could try it with this first to see what it is.
Let's see if I get this one right.
Yeah. Now we have to standing off. So with that sort of thing, you're really testing. You have the points. And you drew from this point to that point, profiles all the way around. Yeah. So you gave us these points, those 4 points. Because those are the placement points, and everything else is just the offsets relative to the placement points. It's actually one that number 5.
So then you draw the
And when I do this, I can actually look at the cash.
when you draw, you can, if you do the short chip,
Oh, exactly. And even after you have this, you can then go through and ask, you better actually draw this separately. Basically, as soon as you, whenever you can create, that line, you can create this line, then you have, somebody create the frame, you have somebody create, yeah. So I think you're okay. It's really just that this is even here. A consequence of the profile is it's very well. I really want to stick to that point. So, I was shortcutting, but really what you do is how we do this one. go ahead and create those interior points that you follow. As soon as you get interior points that you follow, then scale those points back. Sure, that's something I think. So make sure the direction. Yeah, exactly. Placement points. I'm talking about your panel. How do you want your panel to be consolidated that one that's what your panel will begin? Like that, so it's in on either side and or how do you want it to end? It's tricky in terms of like, how big that is. And even if I look at it in this will be right up on it. Yes, I think it's rich now. That was especially tricky because it's only have this position. So we have a panel. Over there. Yeah. That's okay. Generally, as you place the panel, you get to choose whatever you're doing outside or inside. But as I draw this, even whether I'm on above or below, makes a difference in terms of whether, as you do this, like, this would be the collide. That's fine. I believe it's above that, actually. But also, there's another thing you can do, which is that actually does something very cool. A simpler tool is that. What we did here by offset is actually be perpendicular to the point. And the point is there that as the challenge is that there is will always be resistance. You can make up a corner that meets this as a first approximation. Just making sure that it does this. It's pretty good. And later on, this is much easier to do that, and then we just sort of like some sort of a cap in the corner of every corner. It's different points of different depending on how out of planes, so that's a kind of good decision. You want to have every corner that's kind of the data that you want, or those are the ranges all the between special molding. That's really I can't tell. As soon as you square it out, it's easy to tell. But if you don't put a round one, you don't have now. But if I still have glass, and go around, and here, and go around. I could rotate that any way you would be able to tell. So that's for the question you watch the proof, for demonstration, for code design and manufacturing. You have to realize that you will not see the okay. You're on, that whole thing with the offsets and the video, get those two items together. You're really close. It just won't leave. I'm going to leave. Because I tried a lot to come up with the 9s. Yeah, she's got it. She's got a couple.
I'm like, yeah, man.
She's going to come up with the 9 grids. doing title shifting. Everyone finds it a lot. Henry's going to come up with a nice Python interface for apps that we can't get to. What's to do. Subdividing tasks on small scales in the room. There's a lot of talent in this room. Everyone wants to do pieces of it. Story about that. Do they have you vexed with a problem?
So yeah, I mean, I think I'll just change the shading here. There's something slightly wrong with this, but I guess I'm satisfied with it. But it does demonstrate that how we can make a sort curve component. So for those who are curious, yeah. All right. So the first step though is to make a kind of adaptive component that's not based on lines. This actually perhaps looks almost identical to the other one, but you'll note that it's got curves. I should probably change the inset to something more sensible here, like 1 foot. I use spline through points. Yeah. And
For 4 different boundaries.
so the 4 different boundaries. Yeah. So this basically will allow us to adapt. I think the inset is actually a straight line, so it's making kind of weird doubly curved surface, but you could improve on this or change the mullion to whatever you wanted.
You have 8 points that are necessary.
8 points that are necessary. So I hate to say it's like how did I then actually instantiate these on the actual form? I just imported it in, and yeah, the trick is basically a Python script that I will share with you. But essentially, I'm just iterating through all the values. I know. Yeah, I'll share this with you. It isn't nearly as complicated, perhaps, as it might look. Essentially, I'm just creating 3 different U values, 3 different V values. You can see from this kind of MS Paint diagram. Hopefully, this makes any sense.
This
Yeah.
makes perfect sense what you do with this.
Okay. Yeah. So I mean, I'm just kind of dividing it like this, and then I'm just selecting, kind of choosing things from here. And this will work, of course, for yeah.
Even more clever. Okay. Yes. Yeah.
So this should work if you just sort of copy and paste it into your script or use it there.
The key is to just keep that line instead of straight line.
Yeah, pretty much. Nothing much to more to it. I think the hard part is you can't just use the quad points on face. So you have to come up with your own way to pick. And what this will do is create 8 new points along this parameter range.
This is clever. So as opposed to grabbing, taking the points and making collections of 9, just sticking with the 4 points, but then subdividing it.
Yeah, it's kind of because I'm basically I'm making up these 3 UV values.
That makes sense.
Yeah. Maybe that's easier. So okay, we'll let you go with quads, and I'll subdivide a quad at a time.
That could also work. Yeah, there's many ways to do it. I mean, this is more intuitive to me, but I'm hoping, I think this should be kind of obvious. This is doing pointed parameter. This is just making a list here. So this is the only math involved, which I think you could probably edit yourself.
I like this. I think this is quite clever.
Okay.
This is good.
Good to hear. Yeah, and again, I don't know what's going on here. It's probably just too late in the day, but.
Things stop working after 8.
Yeah, exactly. But I think it's just there's like an offset that's flipped or something weird. I don't know.
There's just some little funky thing going on. No,
Yeah.
that's your. I think you've given us the key to unlock the.
Oh, fantastic! Yeah, that's really good to hear.
Now it's just sort of mucking with it. But
Yes.
Okay. Yes. Okay.
Do you need 3 points on each segment? Is that because it's one?
I mean, yeah, that's one way to do it. You could have as many as you wanted, really, and of course you could modify this script to, well, you could use something like a loop or something that's not just copying and pasting here. Like there's no inherent limitation to 3. You could add more stuff here, make it into 5. You could turn it into 10. And that would get a more precise spline fitting on the exterior of the building.
The way you're doing it is actually, it's much more clever because it's easier to subdivide than it is to collect the points.
Yeah.
Yeah. I don't know why that is. It's, yeah, given what you're doing, it's easier.
I mean, sometimes, yeah, Python can just help with, like, list management problems can be very difficult when you're trying to do it completely graphically. But again, I still prefer composing a lot of the scripts that you're writing in graph form. So, yeah.
So use tools. Use 2 points per segment.
Yeah, if I kept the adaptive component exactly the same, it just would be just like the one you had before, but with spline. But the thing is, if you make it a spline and you add a third point, then it can do the curvature.
And it just gets more accurate.
Yeah. Yeah, exactly.
The more finely subdivided, with that point, yeah, it's just gonna get tighter and tighter.
Of course, typically though, you never would even have a spline as your facade element because you can't easily manufacture a spline. You can take exactly. I mean, you know this. Like you can take a piece of pipe and bend it into arcs, right? So then you're splitting it into arc segments, or they're straight segments. But you would never just say, I have a point or some point, just fit an arbitrary curve through that. It's typically rare. So be careful, I guess would be the other thing to say, yeah. Another way, yeah, you could easily do an arc. Actually, that might be more rationalized, but it might have it wouldn't have the continuity, the smooth continuity on the outside.
Yeah, Zach did that as an approximation he did, I think, largely out of that consideration.
Yeah.
Mathematically make this all work. In terms of what's actually manufacturable, we can do all this simplifying.
Yeah, or you could say it's CNC. Like CNC devices, you can of course make splines, but yeah, and those are becoming more accessible now. So anyway, I'll share all this stuff with you. Is there anything else? Like any last questions people have? Okay, cool. Yeah, you're gonna have one all night, but yeah, no. What is it?
So I'm making these booleans. General control.
Sort of. Not really.
So